You're crouched at the mouth of a cave in northern Spain. The air smells like wet stone and wood smoke. Your knees ache from the cold ground. It's 42,000 years ago. You're not the interesting one here. That's the guy hunched by the fire, jaw like a boxer's, brow ridged thick enough to rest a coffee mug on, shoulders built for hauling carcasses, not lifting a laptop bag, brain slightly bigger than yours. On paper, he's winning. Better specs than most dating profiles promise. Within a few thousand years, he and everyone like him will simply stop existing. Not evolve into something else. Not blend in completely. Stop. You've probably heard the textbook answer, dumb cavemen, smarter humans showed up, game over. That answer is mostly wrong. And the real one was hiding inside their own bones the whole time. Here's why this isn't just old bones. If your ancestors came from outside Africa, some of those bones are basically still walking around, inside you. Right now, somewhere in your DNA, there could be a little Neanderthal quietly running the show. Stick with this one, because by the end, you'll probably wonder about your own gene pool. So this isn't really a story about them going extinct. It's a story about how close extinction actually sits, even when, on paper, you're winning. Start with the basics. Because the basics already break the stereotype. Neanderthals weren't a failed rough draft of humans. They ran Europe and parts of Western Asia for roughly 350,000 years. That's not a typo. Homo sapiens as a species hasn't even hit 300,000 yet. Neanderthals survived ice ages that would flatten a modern supply chain in about a week. No heated apartments. No down jackets shipped overnight. Just fire, animal hide, and a body built like a furnace. Their rib cages ran broader than ours. Their limbs shorter. Their whole build compact. Engineered by evolution to hold on to heat. Even their noses were bigger, built to warm freezing air before it hit their lungs. You'd probably lose a shivering contest to a Neanderthal in about 4 seconds flat. They weren't running on instinct alone, either. Neanderthals made sophisticated stone tools using something called the Levallois technique. It meant carefully shaping a stone core so a single strike could pop off a nearly finished blade. That takes planning. You have to see the finished tool before it exists, the same way a woodworker sees a chair inside a plank. They hunted animals twice their size using wooden spears, working close enough to smell the thing's breath. That's not a metaphor for bravery. That's Tuesday, if you were a Neanderthal. They also controlled fire deliberately, building hearths inside caves, not just using flames they stumbled across. Think about how much of your day quietly depends on some version of a hearth, your stove, your heater, that charging cable keeping your phone alive. Strip all of that away and see how your evening goes. For a long time, researchers didn't actually know when Neanderthals died out. Old bones are hard to date precisely. Early radiocarbon methods were sloppier than people wanted to admit. Even a tiny trace of newer carbon contamination could make a genuinely ancient bone look thousands of years younger than it really was. That changed in 2014. Archaeologist Tom Hyam led a team that redated dozens of Neanderthal sites across Europe. They used improved radiocarbon techniques and published their results in the journal Nature. Their conclusion: Neanderthals didn't vanish all at once. They disappeared in a staggered, region-by-region pattern. The last confirmed populations were gone by around 40,000 years ago. Here's the detail that matters. That's not a clean handoff. Modern humans had already been living in parts of Europe for thousands of years before the last Neanderthals disappeared. 2 different human species, sharing a continent, sharing rivers, probably sharing campfires more often than we assume. If Neanderthals were simply worse at surviving, you'd expect a fast, brutal replacement. Instead, you get thousands of years of overlap. Then, quietly, one species stops showing up in the fossil record. Now here's the complication. The old assumption, the one most documentaries lean on, is that modern humans were simply smarter. Bigger brains for planning. Better tools. Better language. Neanderthals just couldn't keep up. Turns out, that story doesn't survive contact with the evidence. In 2010, archaeologist Zhu Zielho and colleagues published research in the Proceedings of the National Academy of Sciences. At sites including Cueva de los Aviones and Cueva Antin in Spain, they found Neanderthals using pierced marine shells and mineral pigments. Some shells were strung as jewelry. Others were hollowed out and used as tiny containers, holding mixed pigment residue. Basically a prehistoric makeup kit. All of this was found in layers dating before modern humans had even arrived in the region. That's not survival behavior. That's jewelry. That's a creature thinking about how it looks, not just how it eats. Then in 2018, a team led by geochronologist Dirk Hoffman published dating results in the journal Science. The subject, cave paintings at sites including La Pasiega in northern Spain. Using uranium-thorium dating on the mineral crusts covering the pigment, they calculated the art was at least 64,800 years old. Modern humans hadn't reached that part of Europe yet. The only candidate left holding the paintbrush is a Neanderthal. Somewhere, an ancient art teacher is owed an apology. And there's more. In 2012, researcher Karen Hardy and colleagues published a study in the journal Naturwissenschaften, examining dental plaque from Neanderthal teeth at El Sidrón Cave in Spain. Buried in that plaque, cooked plant starches, plus chemical traces of medicinal plants like yarrow and chamomile, plants with no nutritional value, but real pain relief properties. Translation: this looks like self-medication, a Neanderthal reaching for the right plant on purpose. Then there's Shanidar Cave in Iraq. Several Neanderthal burials were found there, deliberately placed, not just left where they fell. One famous case was surrounded by pollen clusters that early excavators argued came from flowers. Later, researchers pushed back, suggesting burrowing rodents instead. That detail's still debated. The burial itself isn't. Somebody dug a grave and chose to fill it carefully. So the dumb caveman version doesn't hold up. These were creatures with symbolic thought, personal ornamentation, and possibly their own version of a medicine cabinet. In other words, they weren't outthought. Something else happened. And that's the open loop this entire video is built on. Turns out, the fate of the Neanderthals didn't just end in extinction. It also ended in a very awkward family reunion. In 2010, geneticist Svante Pääbo led a team at the Max Planck Institute. They published the first draft sequence of the Neanderthal genome in the journal Science. The genome came from bone fragments found in Vindija Cave, Croatia, tiny scraps that had been sitting in a museum drawer for years before anyone could actually read them. The findings stunned the field. Neanderthal DNA showed up inside the genomes of people whose ancestry traces outside Africa. Usually somewhere between 1 and 2% of the genome, in people of European and Asian descent today. That means, at some point, Neanderthals and modern humans didn't just share territory. They had children together, repeatedly across thousands of years, and multiple regions. This wasn't one awkward encounter around a shared fire. Pääbo's later work eventually earned him the 2022 Nobel Prize in Physiology or Medicine. That research helped establish that interbreeding happened more than once, in more than one place. So if you're picturing extinction as one species violently replacing another, stop. Genetically, part of what happened looks more like absorption. Neanderthals didn't just lose. In a strange way, some of them got folded into us. You're reading this on a phone, in a room with better climate control than any cave in Ice Age Spain. You might be carrying Neanderthal genes right now. Genes tied to skin, to immune response, even to sleep patterns. That's not metaphor. That's published genetics. Your allergies might technically be an inheritance. Here's where it gets interesting, because interbreeding wasn't the only thing hiding in that DNA. It also revealed something Neanderthals probably never knew about themselves, how small and fragile their population really was. In 2014, a separate team led by geneticist Kay Perfer sequenced a far more complete Neanderthal genome. This one came from a toe bone found in Denisova Cave in Siberia. Published in Nature, the results showed something startling. Her parents were closely related, likely half-siblings or an uncle and niece. That's not a one-off finding either. A 2017 population study by researcher Alan Rogers and colleagues, published in the Proceedings of the National Academy of Sciences, dug further into the numbers. Their estimate: Neanderthal populations stayed small for most of their history, likely only a few thousand breeding individuals, spread across an entire continent. Think about your own extended family for a second. Cousins. Second cousins. The ones you barely recognize at reunions. Now imagine that's most of the eligible people within 1,000 miles. Compare that to a single modern city block, and it sounds impossible. Now spread those few thousand people across all of Europe and Western Asia. Cut them off in small pockets, split by mountains, rivers, and ice sheets. You get a population one bad winter away from trouble. Small populations lose genetic diversity fast. Genetic diversity is what lets a species adapt when the environment shifts. New diseases, new predators, new weather nobody's built for. Neanderthals had apparently been running on a thin margin for tens of thousands of years, long before modern humans ever entered the picture. So pause for a second. Two species. One with a much bigger population, spreading fast, building loose networks between groups. The other running on a few thousand people, with shrinking genetic options and thinning connections between bands. If you think you already know where this is going, stick around. Population math alone doesn't explain everything. And the next piece involves a volcano that never made it into your school textbook. Let's talk about the environment they were living in, because it was brutal, even by Ice Age standards. Neanderthals survived some of the most unstable climate swings in Earth's history. Climate scientists call the sharpest of these swings Dansgaard, Oeschger events, regional temperature jumps that could hit within decades, not centuries. Warm, then brutally cold, then warm again, over and over, for tens of thousands of years. Imagine your hometown swinging between brutal winters and sweltering summers, decade after decade, with zero warning and no weather app to prep you. You'd learn to adapt fast, or you wouldn't last long. Add to that a genuine wild card, the Campanian Ignimbrite eruption, a massive volcanic event, centered near modern-day Naples, roughly 39,000 years ago, among the largest eruptions Europe has seen in the last 200,000 years. Researchers, including archaeologist Lyubov Golovanova, have proposed a link. The ash and sulfur it threw into the atmosphere may have driven years of cooling across parts of Europe. That timing lines up uncomfortably well with the last Neanderthal populations vanishing. To be clear, this part is genuinely debated. Not every researcher agrees the eruption was severe enough, or precisely timed enough, to be a direct cause. That uncertainty isn't a cop-out. It's simply where the field honestly stands. Absence of certainty isn't the same as absence of evidence. But layer it onto everything else. A population already small, already inbred, already stretched thin across a shrinking, unpredictable landscape. You don't need one knockout blow when a species is already this fragile. Think of it less like a single punch, and more like death by 1,000 bad winters. You just need one more bad decade. But here's the question that should be sitting in the back of your mind by now. If Neanderthals were smart, adaptable, and had already survived worse climates before, why didn't they simply recover the way they always had? In 2019, a team led by researcher Christ Vason published a modeling study in the journal PLOS One. Their goal: run the numbers on exactly that question. They built population simulations using realistic Neanderthal group sizes, split into small regional bands, 20 people here, 50 there, scattered across hundreds of miles. Barely a neighborhood, let alone a nation. Then they tested something specific. Could Neanderthals have gone extinct from internal demographic pressure alone? No disease required. No violence. No volcano. Just math. The model showed something striking. Small, inbred populations are genuinely fragile when something called an alley effect kicks in. You've probably watched a low-stakes version of this happen. A group chat loses a couple of people. It goes quiet, loses a couple more, and eventually just dies. Nothing dramatic, just fewer and fewer people left to keep it alive. An alley effect is that same logic, except survival is the stakes, not group chat energy. A shrinking group starts struggling to find mates, defend territory, or bounce back from ordinary bad luck. The group gets so small that being small becomes the actual problem, on top of everything else. According to the model, populations like this could plausibly collapse entirely within around 10,000 years, purely from within. No outside villain necessary. Now stack modern humans on top of that. Genetic and archaeological evidence suggests Homo sapiens arrived in Neanderthal territory in larger, more interconnected groups. Wider social networks, stretching across greater distances, closer to a modern supply chain than a single family camp. Archaeologists have found ornaments and raw materials moved hundreds of kilometers between early Homo sapiens sites. That kind of movement only really works if separate bands are staying in regular contact, trading, and probably intermarrying with each other. Neanderthal sites don't show that same long-range pattern nearly as often. Every resource a Neanderthal band needed, a nearby Homo sapiens group was probably also using, not with spears drawn, just by existing, in larger numbers, more often, in more places, with more backup if one bad season hit. A demographic squeeze, not a war. Paleoanthropologists actually have two competing names for this general idea. One is the replacement hypothesis. Modern humans simply outcompeted and displaced Neanderthals outright. The other is the assimilation hypothesis, argued for decades by researchers including Eric Trinkhaus. It says the two populations gradually merged, with the smaller one absorbed into the larger. Recent genetics leans hard toward assimilation being at least part of the real story. In 2020, geneticist Martin Petter and colleagues published research in the journal Science, tracing the Y chromosome lineage in later Neanderthals. Their finding, at some point, the original Neanderthal Y chromosome line disappeared entirely. It was replaced by a version introduced through interbreeding with early Homo sapiens, tens of thousands of years before the more famous, later wave of interbreeding most people know about. Even the family tree was already blending, long before the ending most documentaries show you. Picture what that actually looked like on the ground. A Neanderthal band of maybe 20 people, moving through a valley they've used for generations. One winter, the herds don't show up on schedule. A few members die. There's no larger Group 2 valleys over to send reinforcements. The population's too thin and scattered for that kind of backup. Meanwhile, a Homo sapiens band nearby, several times the size, with contacts in a handful of other camps. Weathers the same bad winter without much trouble. Multiply that pattern across thousands of years and hundreds of valleys, and you don't need a single battle. You need patience. This is the part worth sitting with. If you clicked on this expecting a simple villain, drop a comment and tell me this. Does a species going extinct just from being small, isolated, and unlucky know war? No villain required. Change how you think about your own survival? So here's the actual answer. The one that replaces dumb cavemen lost. Neanderthals didn't lose a war of intelligence. The evidence, Zilho's shell jewelry, Hoffman's cave paintings, Hardy's medicinal plants, says the opposite. They were creative, symbolic, technically capable in ways researchers are still cataloging. There's even a famous 1989 discovery from Kabara Cave in Israel, a Neanderthal hyoid bone. That's the small structure in your throat that helps you form speech. It's shaped almost exactly like yours. That doesn't prove Neanderthals were chatting about the weather. It does suggest the physical hardware for speech was already in place. Combine that with symbolic jewelry, medicine, and deliberate burial, and primitive stops being the right word entirely. What they lacked wasn't brain power. It was numbers, and the genetic depth that comes with numbers. Small, scattered populations. Repeated inbreeding, confirmed straight from ancient Dina. A brutal, unstable climate that occasionally got worse, possibly with a volcanic assist, around 39,000 years ago. And then, on top of an already fragile system, A new human population arrived, one that outnumbered them, outnetworked them, and in some cases, quite literally outloved them. Interbreeding folded a portion of Neanderthal ancestry directly into us, right down to the Y chromosome. Call it demographic swamping. Not one dramatic extinction event, but a slow statistical squeeze. It played out over thousands of years. Picture it less like a battle and more like a species running on a bank account that never had quite enough saved in it. Then came one unplanned expense after another. A cold snap, a bad harvest, a rowdier neighbor moving in next door, until the balance quietly hit zero. No dramatic final withdrawal, just years of overdraft. A larger, more genetically diverse population could absorb that kind of squeeze. A smaller one simply couldn't. Researchers still argue over the exact weighting of each factor. How much was climate? How much was population math? How much was ordinary bad luck? That disagreement isn't the field failing you. It's the field being honest about a case built almost entirely from circumstantial evidence, some of it 40,000 years old. So go back to that cave in northern Spain, 42,000 years ago. The guy by the fire isn't losing because he's stupid, and he isn't losing because he's lazy, or unlucky in some cartoonish single-event way. He's not really losing a fight at all. He's living inside a population too small, too isolated, too genetically thin to absorb one more hard winter. Right as a bigger, more connected species happens to move in next door. No villain. Just math, running quietly in the background. The same way it still runs in the background of every species alive today, including yours. Every species on this planet, right now, is running the same experiment. Most are just further from the finish line. Picture it one more time, all at once. The fire, crackling low. Shells threaded onto a cord around someone's neck. A bitter plant, pressed against a sore tooth. A grave, dug by hand and filled in carefully, long before anyone called it archaeology. Next time you're scrolling on your phone at midnight, carrying a little Neanderthal Dina you never asked for, remember this. Extinction isn't always loud. Sometimes it's just numbers, running out. The fire went out quietly.